Hello, my name is Mr. Ananisa and my metric is CE240148 from section 3. So in this video, I will present my MATLAB GUI. The goal of this project is to allow users to input electrical values and instantly calculate result from a predefined circuit using matrix equations. This interface makes solving engineering problems easier, more accurate and user-friendly. So let's begin with the GUI layout. At the top of the interface, you will see three input boxes labeled V, A, and R5. They stand for voltage, current, and resistance, respectively. Users are expected to enter numerical values for each of these. In the middle of GUI, there is a large red button labeled Calculate. When clicked, it will trigger the computation based on the user inputs. To the right of the button, there is an axis area. This part of GUI is used to display an image called photo PNG, which can be a visual diagram of the circuit, a reference chart, or anything related to the problem. At the bottom, there are four colored boxes labeled V1, V2, V3, and V4, which are used to display the final calculate results. These outputs are color coded to make them easy to read. Let me now explain how the code works behind the scenes. So first, the image photo PNG is displayed in the axis box using axis handle, axis 1, I'm show photo PNG. Then the code reads the value entered by the user in the input boxes using the coding string double A, B, and C. So A is for current, B for voltage, and C for resistance. The string double function converts the text input into a numerical value. So next coding is the matrix. So the heart of this program is a matrix equation. The matrix was manually derived from a circuit diagram given in the assignment question using mesh or nodal analysis. We analyzed the electrical relationship using Ohm's law and Kirchhoff's rules to develop a system of linear equation. This vector represented by the matrix X and vector Y, so this matrix we obtain in the manual calculation. The matrix X holds the coefficient from the circuit equation, while Y holds the constant based on the input values. The term 1 over 8 plus 1 over C in the matrix means that part of the equation depends directly on the user-defined resistance. So the setup reflects a real-world circuit with a voltage drop, current path, and resistance that we simplify into matrix form during our analysis. So next, solving the system. The code then solves the system of equation V equal X over Y. This gives a vector V which contains the four unknown values from our circuit analysis. We designed each of these values to separate variables, which is V1, V2, V3, and V4. Note that we multiply the fourth value by 2. This scaling might be based on a requirement in the assignment, such as doubling a voltage or representing a power factor. So the last one is displaying the output. The results are displayed in the GUI text boxes using set handle text, which is 4 of them. These lines update the text in the output box with the calculate values. Now the users can immediately see the solution to the circuit problem just by clicking one button. So I'll show you how it works. Just write a value wherever you want. So there will be display output V1, V2, V3, and V4. And that's all for me. Thank you.
Hi, my name is Boniface Slice Anak Bennett and my matrix number are CE240091. Now, in this Simulink demonstrations video, we will have 4 sets of display, 4 sets of voltage sensor, 1 DC voltage source, 5 resistor, 2 DC current source, 1 VCVS, that is our voltage control voltage source, and 4 ground, and 1 solver configurations. Now, what is this Simulinks for? Excellent question. Here is the precise answer. This Simulink is in this project is to simulate real-time behavior of the electrical circuits based on the same input parameters in MATLAB guide. Its main contributions is to serve as a validations tool confirming that the result obtained through numerical matrix calculations are accurate. By constructing all of this circuit in Simulinks using physical component that we can find in Simscape library, we are able to observe how the voltage of each node change in real-time based simulations. This allows us to visualize voltage respond over time, detect possible transient behavior, and cross-check result against theoretical calculations. This Simulink it's provide with an interactive and visual representations of a circuit, which complement the static numerical method used in GUI. It enhances confidence in result and bridges theory with practical simulations. In this Simulink circuit, the one that we can manipulate is DC voltage source and DC current source and our R5. In DC voltage source, we put the number 14. That is according to our calculations, our chosen numbers. We chose the constant voltage for the DC voltage source is 14 volt. And in DC current volts, we choose 7 amperes. And in our resistor number 5, we choose 2 ohm. In order to check if our Simulink align with our MATLAB guide, we press run. And here in this for display is our result. And then if we want to check if it's accurate with our guide, we simply test it out. As we can see, if we put 0, 0, 0 in this space, in this blank space, the result will be 4, 0. But if we put in this first space 14, my bad, 7 and 2, we will have almost exactly the same value as in our Simulink, which is 13.5, 13.15, 3.2, negative 0.8, negative 8.17. In our MATLAB guide, we will have for 13.14, which we can say is 13.15 if we round the numbers. And this is accurate. This one is accurate. This one is accurate. And this one is also accurate. That's it from my Simulink video. Thank you.